Okay, so we are seeing the Booth's algorithm for the third case. Okay, so already I have did for 6 into 2 is equal to 12, and 6 into minus 2 is equal to minus 12. Okay, we have seen in the previous video. Okay, so please subscribe and see the previous videos. Okay, and now we are going for the third case, that is minus 6 into 2. Okay, so this is a time multiplicand is minus, okay, and then the multiplier is 2. Okay, so that is the result, that is the time minus 12. How we have to do it? Okay, so what we have to do is, for any minus sign, okay, so you can't use for the binary value minus in ALU process. Okay, so here in the ALU, how it will do is, it will find out the 2's complement value of 6. Okay, so how we can do initially for positive 6, okay, how we are doing is 6 is 2, that is 3 0, and then 2, and it is 1 1. Okay, so that is 0 1 1 0. Okay, so that is the positive value of 6. Okay, so now when we go for minus 6, okay, so minus 6 means what will be the value? 1 0 0 1, just converting zeros and ones, that is for the 2's complement. Okay, that is for 1's complement, just we are adding 1 to it, you will get the 2's complement value of 6. Okay, so that is 10 and then 10. Okay, so this is the value for 6. Okay, so that is 1 0 1 0. Okay, so that is the value for thing. Okay, so that is the 2's complement value for 6 here. Okay, okay, just adding it, right. Okay, so now for the 2 you will get 2, that is 1 0. Okay, so that is 0 0 1 0 when you write for the 2 bit. Okay, 4 bit. Okay, so that is 0 0 1 0, that is 2, right. So now consider for the 12. Okay, for 12 that is the result, right. So minus 12 means you have to find out the 2's complement. So for positive 12, what will be the answer? That is 6 0, and then 2, that is 3, that is 0, and then 2 1 1. Okay, that is 1 1 0 0 is for positive 12. Okay, so now we find out the 2's complement, that is 0 0 1 1 plus 1. Okay, this is 1's complement. Okay, for 12. Okay, the next is 10 1 10 1. Okay, so this is 0 1 0 0. Okay, so this will be the final result. Okay, so this is how we are going to check it out, how you can do in Booth's algorithm. Okay, so this is the minus 6 and 2 and then minus 12, that is the binary value. We have converted into 2's complement and 2's complement here. Okay, so now consider for the Booth's algorithm, as it is a 4-bit value. Okay, so we have to do 4 steps. Okay, so before that, what we are going to initialize is, we are going to use 2 registers. One is A and the next is a Q minus 1. Okay, so both the thing we are going to initialize as 4 zeros. Okay, and then this is a single bit, so it is 0, and the next is a Q. Okay, so that is the multiplier. Okay, what is the value of 2 here? That is the multiplier, and then M is the multiplicand. Okay, so M is a minus 6, so that is 1 0 1 0. Okay, and the next is the action. Okay, what action you are performing. Okay, so that is very important. Many times the people will not write the action, then they will not know what they are actually performing. Okay, so then the Q is the 2, right. So that is the multiplier. Okay, so that is 0 0 1 0. Okay, so this is the initial step. We are going to multiply M and Q, and we are going to find the result is minus 12, that is 0 1 0 0 at the 4th step, as it is a 4-bit value. Okay, so right. Okay, the first step what we are going to do is, we are going to check the Q0 value. Okay, so this is Q0, Q1, Q2 and then Q3. Okay, so now we are going to find out the Q0 value and q minus 1. Okay, so both are 0. If both are 0 means what we have to do in Booth's algorithm is just we are going for shifting. Okay, and if it is 1 1 also just we are going for shifting. Okay, so these are the 4 steps we are going to memorize in Booth's algorithm. That is, if it is 0 0 means 1 shifting, 1 1 also means we have to just shifting. That just we have to make a right shift. I will explain you how to do it. And the next is if it is 0 and 1, that is q0 is 0 and q minus 1 is 1, then that is the time we have to go for adding, that is a plus m, this a and then this m. Okay, we have to add it, and the next is we have to go for shifting. Okay, and if it is 1 0, that is q0 is 1 and then q minus 1 is 0, that is the time we have to go for subtraction, right? That is a minus m. Okay, so in ALU we can't do subtraction directly. For that what we have to do, we have to make a 2's complement of m and adding with that a. Okay, so just we will check it out. When such steps comes you will be very clear with this. Okay, so now what we have to do is both are 0 0. Okay, so that is what we have to do, we have to go for only shifting. Okay, so shifting right shift means what we have to do is the first bit just we are going to copy as it is, and the next is we have to shift it to the second position. Okay, and this third position to the fourth one. Okay, and then this fourth one to the q part. Okay, and the next is this 0 to 0 and then this 0 to 0 and then this 1 to 1 and this 0 to 0. Okay, and copy the value of m as it is. Okay, so what actions we have performed here, just we are making a shifting. Okay, so once the shifting is over, the first step is also get over. Okay, right? So this is the first step. Okay, now consider q0 and q minus 1. Okay, q0 and q minus 1, now it is 1 0. Okay, so 1 0 means what we have to do, we have to go for subtraction and the next we are going for shifting. Okay, so two process we are going to do for the second step. Okay, so this is the second step. Okay, first what we have to do is, that is subtraction, that is a minus m. Okay, as I told you, a minus m directly we can't do a subtraction. Okay, so what we are going to do is we are going to find the 2's complement of m and then adding the value with a. Okay, so that is see, a minus m is equal to 2's complement of m plus a. Okay, so this is how you are going to do a minus m. Okay, so 2's complement of m. Okay, so m is already we know, right? That is 1 0 1 0. Okay, 1 0 1 0 is m. So 2's complement of m is, what is the 2's complement? Just making a change 1 and zeros into thing. Okay, so you will get 0 1 0 1. Okay, so this is 1's complement, just adding to it. Okay, so that is, okay, so this is the 2's complement value. Okay, so this is a minus m. Okay, so a minus m means we have to add this value with a also. Okay, so already a is 0 0 0. Okay, so anything adding with 0 is the same value. Okay, so just I am copying this value 0 1 1 0 into the a register. Got it? Okay, so this is how the a register will be updated and q copy as it is. Okay, and q minus 1 is 0. Okay, and here also copy it. Okay, so the action we have performed here is a minus m. So after doing a minus m, what we have to do, we have to go for right shift. Okay, so as I told you in the previous step how we did the right step, the right shift, the same thing we are doing here also. Okay, just making the first bit as it is and then this first bit right shift to here and then this is right shift to here and this one will come here and this 0 will go to this position and the next is this 0 will come here and then this 0 will come here and this 0 will come to the position. Okay, and this 1 will come here. Okay, so this is the end of the second step. Okay, so here what actions we have performed, we have performed the shifting. Okay, so recap the second step. So while we are doing a minus m and shifting, we are checking the q0 and q minus 1. Okay, so that's why we are going for a minus m. Okay, so for that we did 2's complement of m and adding with a, and the next is we are just making the right shift to it. Okay, so we are getting the shifted value. Okay, so now we are going to check the q0 value and q minus 1. As I told you, it is a 4 bit, 4 times we are going to do the steps, okay? And 0, 1, what is 0, 1? Here we are going to do addition, okay? That is a plus m, okay? What is the value of a here? That is 0, 1, 1, 1, that is a, and then m, what is the value here? That is 1, 0, 1, 0, okay? So just I am going to add it, okay? That is a plus m. I am going to add and substitute the value of a plus m into the a register, okay? So when we do here 1 and then 10, okay? And the next is 10, okay? And then again 10, okay? So leave the overflow, okay? So just we are going to copy this value it into the a register, that is 0, 0, 0, 1, okay? So 0, 0, 0, 1, okay? And then copy the q value as it is, and 1 and then 1, 0, 1, 0. What actions we have performed here? What action we have performed here? Here a plus m. Got it? The next is we are going for shifting, okay? We should not stop with a minus m or a plus m. Whenever we do this addition or subtraction, immediately we have to do shifting. Then only the third step process will be over, okay? So when we make right shift, what we are going to do? Just we are copying this 0 and then copy, okay? Shift it here and then shift it here, and then this one will come here, and then this 0, 0, and then 0, and this 0 will come here, okay? So what is the action we have performed? That is shifting, okay? Right. So with this, the third step is over, okay? And now we are going to check Q0 and Q minus 1, okay? So simple, right? So both are same, okay? So if both are same, just we are going for shifting. We are not going to do a minus m or a plus m. Clear, right? Okay, so this is a rule of Booth's algorithm. You have to be very thorough with this, and then easily you can solve any type of multiplication, okay? Right, okay. Now just we are going for shifting, okay? So just we are making this 0 as it is copied here, and the next is 0, this 0 will come here, this 0, and then this 0, and then here we are coming this 0, and then this 1, and then 0, and then this 0, and then coming to 0, and then just copying this 1, 0, 0, and what is this? Shifting, okay? So when you find the result here, what is the result? 0, 1, 0, 0, okay? So when you check at the end of the fourth step, what is the value here? 0, 1, 0, 0, okay? So that is the minus 12 to the power 10, okay? So that is the decimal value, okay? So when you find out the 2's complement value, what is this answer you got? Okay, so this is how you got the result at the end, okay? So just checking the Q register, the updated value at the fourth step, okay? So this is the fourth step. So we are in fourth step because it is the fourth, okay? 8-bit value of Q0 and Q minus 1, and we have to do the process, okay? So now we are clear with minus 6 and 2 negative sign also. The negative value, how the 2's complement value of 12, we got it, okay? In the next video, we will see about minus 6 into minus 2, how you are getting the positive value of 12. With this, we can end this series.